We'll kick it off now. So just a bit of housekeeping to start off with. Well, actually, today we're going to be, the topic that we're going to be covering today is mapping the mind. So what MRI and EEG reveals about aging and resilience. So that's a very exciting topic, which we'll get to shortly. So just a bit of housekeeping. As you would have seen, this webinar will be recorded and it will be sent out to everybody that's registered. And so you will be able to access that recording. We've got a good few people in, just coming up to about 150 already. So that's really great. Really lovely to have you all here. We will be having a Q&A section at the end. So just encourage you, if you do have questions during this presentation and masterclass, please use the Q&A function at the bottom of your screen as opposed to the chat function. And we do have a team of people who are there on hand to answer your questions. And then we will have some additional question time at the end. If we don't get to all your questions, then we will respond after the webinar. We will get to all of those questions via email. What we're going to do tonight is we're going to cover eligibility about the courses that we run here, the MHN program. So yes, as I said, please feel free to use the Q&A function during the webinar. So I'd just like to introduce the panel for this evening. So myself, Dr. Chrissy Driver, I'm a course coordinator in the Mental Health and Neuroscience program here at the Thompson Institute at UniSC, and I'm also a researcher in mental health and neuroscience. We also have a guest presenter this evening, Dr. Thomas Pace, who is another mental health and neuroscience course coordinator, and he's a researcher in healthy brain aging. So you'll get to hear from him very shortly. So I'd just like to start by acknowledging the traditional custodians of the land on which we live, work and study, and wherever you are all residing this evening while you watch this webinar. We pay our respects to the local Indigenous elders past, present and emerging, and recognise their strength, resilience and capacity of all Aboriginal and Torres Strait Islander people. So just a quick overview of what we're going to do tonight. I'm going to briefly talk to you about UniSC's Thompson Institute, tell you a bit about what we do. I'll give you a quick program overview of our mental health and neuroscience postgraduate programs, and we'll cover eligibility and some of our amazing student stories as well. And then I'll try and get through that as quickly as possible because I know you're all very excited to hear from Tom this evening, where he's going to be covering our masterclass topic, mapping the mind, what MRI and EEG reveal about aging and resilience. And then we'll finish off with our Q&A aided by the team. Okay, so let's get straight into it. So who are we? At the Thompson Institute, we're a leading mental health and neuroscience centre that very much integrates what we do. So we integrate research, clinical programs, education and training, and advocacy. So the kind of core themes that we have at the Thompson Institute are looking at mental health and brain health issues. So we have a youth mental health program, a healthy brain aging program, which you'll hear a bit more about this evening from Tom. We specialise in post-traumatic stress disorder, which has a lot to do with suicide prevention, and underpinning all of this is a really good research foundation in terms of the neurobiology of mental health. So we're also the National PTSD Research Centre, where our director, Professor Alain Brunet, has a lot of experience in some novel therapies to do with PTSD. And this research centre is the first of its kind in Australia, and it very much brings together advanced neuroscience techniques and also psychotherapies to help treat things like stress-related disorders and new treatments. So I'm now going to give you a very quick overview of our mental health and neuroscience courses, and I promise I'll be as quick as I can, as I know you're really keen to hear from Tom. So we've got 3 programs in our mental health and neuroscience suite. So our graduate certificate, that's 4 courses, our graduate diploma is 8 courses, and the master's, which works a little differently, and I'll explain that soon. And you can see those on the screen there. Now, if you're wondering which one might suit you best, then please do stick around because I'm going to go through the differences and share what our graduates have been doing with their different qualifications, because that's something we do get asked all of the time. So just a quick overview broadly of the programs. They're all fully online. So you can study from home or wherever that works for you, I guess. And in these programs, you'll explore the latest research in mental health and neuroscience. We learn about the new treatments for mental health and substance use disorders and see how all of this knowledge is then applied in, your own professional settings and other contexts. You'll also get insights into the neurobiology behind these conditions and emerging technologies for things like predicting and diagnosing, but also treating these disorders. So you'll learn through UniSC's Thompson Institute, whereas you've just heard, we have research, clinical services, education, advocacy that all come together, and you'll be hearing from a lot of researchers and clinicians in the MHN programs. I will share a little bit more information about the online format shortly, but first let's hear from one of our recent graduates, Marissa, and she's going to explain a little bit about her experience in that program.
My name is Marissa Price, and I'm a secondary school teacher at an all-boys college where I teach psychology, legal studies, and English. Working in secondary education, I can see daily how crucial neuroscience is for understanding behaviour, cognition, and emotional well-being. The grad dip offered me the chance to build foundational knowledge, and it quickly began transforming how I engaged in my teaching role. The units on youth mental health and biology, stress-related disorders, and understanding and preventing suicide were not only fascinating, but also gave me practical strategies for supporting struggling teenagers. What I've enjoyed most about the MHM program is how interdisciplinary and applied it is. It's not just theoretical, it's learning that's relevant and transformative. I particularly appreciated how the content helped me connect contemporary scientific research with human experience in meaningful ways.
Okay, so as you've just heard from Marissa, she's a high school teacher. And if you've joined any of these webinars before, you'll know that we have students that come from all sorts of professional backgrounds. And you can see some of these on the screen, including teachers, a variety of health professionals, PR managers, and many, many more different professions. So it's really exciting because this diversity really shows how relevant mental health is across so many careers today. So because the programs are fully online, we also have students from all over Australia and some that are even living overseas. And so one of our current students, Beck, who works in PR, said that she finds it really inspiring to see people from different walks of life coming together to learn how they can better contribute to the world and their communities.
My name is...
So I'm going to give you a quick overview of all three of the programs, which, as I said, are all asynchronous and fully online. So we'll start with the graduate certificate. So in the graduate certificate, we cover, the major mental health disorders across the lifespan and the neuroscience behind them. So we look at things like trauma, neurodiversity, mood disorders, eating disorders, and substance use, PTSD, and also dementia. But we also look at current and emerging treatment approaches and look at imaging related to mental health as well. Next, we dive into youth mental health and we explore issues like cyberbullying, suicidality, and social connectedness, and how all of these experiences impact the brain, particularly in that really crucial developmental period of adolescence. Then we introduce you to neuroimaging techniques like MRI and EEG, and you're going to hear a little bit more about those modalities shortly from Tom, but also how they've advanced diagnosis and treatment, plus some of the emerging brain-based biomarkers that are coming out in the research at the moment. And finally, we tackle suicide prevention, so looking at strategies across society, including things like lived experience perspectives and different unique factors for priority populations. So the graduate certificate is available part-time, and it's a really good place to start if you're testing the MHN waters or you want a shorter qualification that still gives you the fundamentals. So here's what some of our students who have completed our graduate certificate have said about the course. So this comes from Ian. So the graduate certificate has been of enormous benefit. I've applied relevant aspects positively in advocating for better inclusion and neurodiversity in the workplace, prevention of psychological harm, intervention with FIFO workers struggling with their mental health. I had such a positive yet challenging study experience in completing my graduate certificate. but I have no hesitation in recommending an MHN course to anyone who has a passion for learning in this field. You will not be disappointed, and it will change your thinking and enhance your knowledge forever. What a testimony. I love that. So in terms of eligibility, candidates will need a bachelor's degree in any discipline or completed a recognised AQF diploma level qualification and have 3 years full-time relevant work experience in a mental health setting. Okay, so the graduate diploma is made up of 8 courses, and this includes the 4 courses from the graduate certificate, plus 4 more where we take a deeper dive into specific areas of mental health and neuroscience research. So here's what those courses cover. In healthy brain aging, you'll explore the neuroscience behind healthy aging, mild cognitive impairment, and dementia, including risk factors and current and emerging treatments. In our neurocognition course, this looks at how different cognitive functions are affected across disorders and also the neurobiology behind treatments for cognitive impairments. In our stress-related disorders course, we unpack the neurobiology of stress and trauma and review evidence for current and novel treatments for conditions like PTSD. Then we have our lifestyle factors in mental health course, and this focuses on how lifestyle is shaping prevention and treatment in this space. And again, we look at the neurobiology behind these factors and the benefits of multi-domain approaches to lifestyle medicine. So as you can see, the graduate diploma takes you to that next level, giving you that deeper knowledge on key topics and plenty of opportunities to apply what you learn in your own professional context. So what do our students say about the graduate diploma? So Katie completed this course as a means of bridging her undergraduate studies in psychology to a master's in occupational therapy, and now she's actually completing a PhD in dementia research. She said, learning alongside students from varied backgrounds fostered discussion and critical thinking that furthered my understanding of the multidisciplinary applications of research. The coursework encouraged us to research topics relevant to our diverse disciplines and interests, while challenging us to widen our scope of what neuroscience encompasses. She said, this course permanently changed how I view mental health and believe the insights gained will continue to influence my practice for many years. Cassia, who's a psych graduate and behaviour specialist, said that within a month of completing the graduate diploma, she was offered a position as a child and family wellbeing practitioner, where she provides holistic services to Aboriginal and Torres Strait Islander children and families. She said that her MHN studies have greatly enhanced her understanding of mental health issues and effective intervention strategies, and the skills acquired during the program have been invaluable in refining her therapeutic approaches and also improving her quality of care. So what are our students doing with this? So for many of our students, the graduate diploma is about becoming more specialised in their current profession. So that is gaining a deeper mental health and neuroscience knowledge to better understand their clients' needs. Others take it as part of a career change, to follow their passion, or simply for personal growth. We've also had students use the graduate diploma as then a stepping stone into medicine. Some complete it to strengthen their resumes, apply for senior roles, or even move into more mental health and wellbeing positions within their organisations. And what we're hearing and what we're seeing is with so many workplaces now prioritising health and wellbeing, having this knowledge is a real advantage. It's helping organisations prepare for future with diverse skills in their workforce. So in terms of eligibility, to enrol in the graduate diploma, you do need an undergraduate degree in a relevant discipline. Now, this could be science, medical science, nursing, medicine, psychology, health science, pharmacy, counselling, occupational therapy, paramedicine, speech pathology, or social work, etc. But that list is not exhaustive. So if you're not sure, then just pop your degree in your application. Now, if you don't have a relevant undergraduate degree, then perhaps the graduate certificate might be a good place to start. Remember, these courses are nested, so you can always start in the graduate certificate and build on that to the graduate diploma. Okay, so now onto the master's program. Now, this includes all of the graduate diploma courses that we've just gone through, but it finishes with a research project. So here's how it works. First, you'll complete the graduate diploma, and then you'll complete the research principles course, which introduces you to the different research areas in mental health and neuroscience. The next part is a supervised research component. So this involves, firstly, a comprehensive literature review on a chosen topic, and then an empirical thesis that makes an original contribution to the field. So with that research, you generally work with existing data sets that are often part of larger research programs. So your project builds on this ongoing research that's already in progress. So if research is really what you want to do and you meet the eligibility criteria, you can apply directly to the master's. On the other hand, if you're more interested in the content without the research component, then the graduate diploma or graduate certificate might be a better fit. And if you're unsure, you can start with one of those and see how you go and apply for the master's later. Just a quick note on the master's, because it is a supervised research project, the places are very limited, and this is to ensure that we can offer really high quality projects. And so the quota does change each semester. Unfortunately for now, applications for trimester 1 have closed, but you can still apply for the graduate diploma or the graduate certificate right now to start in trimester 1 in 2026. So eligibility for the master's is similar to graduate diploma, but we also ask for a personal statement about your motivation for choosing the master's and how your background aligns with the program and research opportunities. So we're now going to hear a little bit more from Marissa, who did complete the master's.
In mid-2024, UniSC launched the master's program, just in time for me to scrap my planned semester off and dive deeper into adolescence and cognition. And honestly, understanding how adolescent brains work is pretty invaluable when you're deciding how to teach them. The lifestyle and mental health unit, for example, really challenged me to think differently about how I support my students, especially when it comes to sleep, diet, and emotional regulation. The knowledge I've gained has had a direct impact on my work. I'm more confident interpreting research, explaining complex mental health concepts to both colleagues and students, and in teaching my own psychology classes more effectively. Statistics has never been my strong suit, but thanks to the patience of the MHN staff, I now provide far richer learning experiences for my own students. I feel equipped to lead interdisciplinary projects grounded in neuroscience and mental health through projects that produce measurable outcomes, not just anecdotal insights.
Okay, so we know that postgraduate study can be expensive. So here's some great news for those of you who are considering the graduate certificate or graduate diploma. Both currently have Commonwealth supported places, which means they're offered at a significantly reduced cost, as you can see here. Now, the master's isn't part of this scheme at the moment, so it is full price. So this is something to keep in mind when you're deciding which option you think might work best for you. So next, we're going to cover some of the common questions we get from prospective students and share advice from our current and past students. So one of the most frequent questions is, how much time do I need to study each week? Now, our program follows USC's usual trimester dates, so you'll have about 12 weeks of content. But because everything is fully online, you can choose when and how you study. If you like structure, you can follow along week by week with guidance from your course coordinator. But if you prefer flexibility, you can work at your own pace. The entire course content is available from day one, so you can plan your assessments straight away. The only requirement is that you submit your assessments by the due dates. So as a guide, the university recommends about 10 hours per week per course. Now, our modules are designed to take a couple of hours each, and if you choose to do the optional activities, this will add more time. Beyond that, it's really up to you how much time you spend on self-study and assessments. We find that most of our students work part-time or full-time, so many choose to study part-time for a better balance and deeper engagement with the content. But we do also have students who manage a full-time load. It really depends on what works best for you. Advice from some of our previous students, Lisa and River, who both did the graduate certificate part-time. Both Lisa and River worked full-time, so studied part-time, and recommended using planners and compartmentalise by blocking out time each week to focus on your study. So this is another big question. What is online study really like? And if you haven't done it before, it can feel a little bit different at first, but most students do adjust quickly. So there are no specific lectures or tutorials to attend. It's a lot more flexible, but it does mean that you do need to be proactive and manage your time. So instead of these traditional lectures, our content is packaged into interactive modules that you can work through at your own pace. Now, after the webinar, you're actually going to get a sample module so you can see what it looks like and get an idea of what you would be working with. So because everything's online, you can structure your study around your work and life commitments. And yes, the modules can even be viewed on your smartphone. But there are also plenty of opportunities to connect with others through discussion boards. We have optional Zoom drop-ins and extra activities that are designed to consolidate your learning, but also prepare you for assessments. Now, these are the type of activities that you would find in a class tutorial or workshop, but in the online setting, they are optional. So you can choose what works best for you. The only non-negotiable, as I said, is completing and submitting your assessments on time. So feedback from Riven was that the course was really informative, engaging and empowering, and you could be as autonomous or collaborative as you wanted to be. The online format is easy to navigate and everything had been thought of. In the rare case that there was an issue, staff very receptive and responsive to make improvements. Next big question we get asked is, how much neuroscience is in the course? The answer is lots. Neuroscience is a rapidly growing field and has become quite popular lately, thanks to some very high-profile podcasters. So it's a really exciting time to actually be learning about the brain. But we don't expect you to finish the program knowing everything about the brain. But we do cover neurobiology, imaging techniques, and more. Now, some courses lean more heavily into neuroscience and others a little less, but overall it is definitely a true blend of mental health and neuroscience. But that's what makes this program really unique in Australia. It's not mental health with a sprinkling of neuroscience. It's definitely a balanced mix of both. And you'll get to hear a bit about the neuroscience from Tom soon. Now, most students do find the neuroscience content challenging at first. Obviously, it's like learning a new language, but it does become more manageable as you progress, and you'll start to see some recurring themes across the courses. It is worth noting, though, that while the internet is full of amazing mental health and neuroscience content, this program does go deeper. Through our assessments, we really encourage you to develop strong science communication skills, and as our program coordinator, Professor Herman, says, to be a healthy skeptic. So that means digging into the literature, considering all sides of the evidence, and evaluating the findings in the context of your own profession or personal experience. So we use a variety of assessment styles to give you opportunities to demonstrate your science communication skills across different contexts and audiences. Now, some feedback from our graduates along these lines. So the teaching staff do a great job at breaking down incredibly complex topics that they were easy to understand. And the information our cohort is studying is really current. Developing an understanding of the different cutting-edge brain imaging techniques has been fascinating, and I was amazed to discover the course covers such a broad range of topics. So finally, it's super important to know that as online students, you still have access to all the same support services that on-campus students get. So this includes academic support, student wellbeing services, accessibility services, and much more. Plus, you'll get plenty of support from your course coordinators through the discussion boards, the optional Zoom drop-ins, and also regular check-ins with study tips and helpful hints throughout the semester. So our students wanted to share the following with you. I was afforded high levels of support and access to supplementary resources to solidify my understanding of complex content, and through the many Zoom drop-in sessions which were offered to discuss content and assignments. Zoom meetings are a great mechanism to check in with the course coordinator and ask questions, see other students, and also understand different points of view on assessment topics. So let's just get a quick wrap up from Marissa before I quickly tell you how you can apply.
The online format has been a major strength of the MHM program. As someone balancing full-time work, study, and parenting, being able to learn on my own schedule has made a huge difference. Support from coordinators, forums, the library, and peer discussions are always accessible and encouraging. The materials were well structured and engaging, which kept me motivated and connected, even in a remote learning environment. If you're considering any of the MHN courses, my advice is simple: do it. Be ready to be stretched, to grow, and to discover new ways of thinking. It's an investment not just in your knowledge, but in your capacity to make a meaningful difference in your field, your community, and in your own understanding of the human brain and mind. It's a fascinating subject that never gets old.
Okay, so finally, how do you apply? Well, so trimester, sorry, I got confused in my semesters and trimesters. Trimester one applications for the graduate certificate and graduate diploma are very much still open and will be for a very long time. You can apply directly online through the USC website. Please do check the eligibility criteria and try and include all the necessary information in your application just to make that process easier. Now, if you're not sure if your qualifications and experience are appropriate, you can always speak to Student Services for advice. They're very helpful with understanding that kind of information. So thank you for listening. I know you're keen to hear from Tom, so I'll now pass over to Dr. Tom Pace, who's going to take you through an amazing masterclass.
Thanks, Chrissy. Hello, everyone. My name is Dr. Thomas Pace. You can call me Tom, and I'm just going to be doing a masterclass on mapping the mind, what MRI and EEG reveal about aging and resilience. So we can begin. So first, what is aging? Biological aging refers to the gradual and inevitable process of physical and cognitive changes over the course of your life. And these changes are a normal part of the life cycle. So you can see aging as sort of natural progression or natural change. And over time, you might notice physical changes like decreased muscle mass, reduced skin elasticity, hair loss. Cognitively, aging may bring about slower cognitive processing speed, or difficulties in multitasking, but not necessarily a decline in intelligence or wisdom. And lastly, daily activities might require more effort or need more support. So Jennifer adding glasses to her wardrobe might infer some declining eyesight, but that it isn't something we would automatically relate to a pathological condition or disease. And so with that comes some common misconceptions about aging. So while some cognitive functions tend to slow, significant cognitive decline is not a universal aspect of aging. We all know some grandparents who appear much sharper than their own children. Aging is not uniform, so different people age in many different ways and at different rates. And then there's this misconception about it being irreversible. So somehow, in this case, Hugh Jackman has become more muscular at 50 than when he was in his 20s. So certain age-related changes, particularly in physical fitness and some cognitive functions, can be slowed or partially reversed through lifestyle choices like exercise and mental stimulation. Of course, Hugh's change isn't necessarily achievable without some pharmaceutical help. But my mother is 70 and she does Pilates, and I can tell you she can hold a plank far longer than I can. So we always hear people relate aging to sort of a physical and mental deterioration, that improvements are kind of a thing of the past, but improvements are definitely achievable for everyone, and this includes your brain health. So to understand our brain health, there's a few major structures that I just want to explain today. Two out of the three of these are gray matter and white matter. So as you can see here, the gray matter is referring to this outer layer of the brain, and in certain specific deep structures, you can see it as the sort of darker area, the darker pink here. And then there's white matter located beneath the cortical gray matter, that forms tracks to connect different brain regions. And so in the next slide, as we zoom into these structures, what you can see here is that in the gray matter, that's where the neuronal cell bodies are, a lot of the dendrites and the synapses. So that's a lot of where the communication chemically is happening and computation is happening between different neural cells. And white matter is mostly these axons that are leaving the gray matter to transmit those signals between different areas of gray matter. So if we go to the next slide, we'll see that because of this neurobiology, gray matter is seen as sort of the cities of the brain that do a lot of processing and computation, and white matter is seen as the highways that take that computation to different areas of the brain. The next slide. And so the other major structure in the brain is ventricle volume or cerebral spinal fluid. You can kind of see this as the plumbing of the brain. It brings in a lot of nutrients and also washes away a lot of waste. So this is an important function when it comes to sleep, where you wash away essentially a lot of the waste that happens through regular neural activity as well. And so they're the sort of three major brain structures: white matter volume, gray matter volume, and ventricle volume. And as we see in this next slide, they're normal growth rates over time. So over the lifespan from infancy to early adulthood, you see this increase in gray matter and increase in white matter. But once we get into sort of middle adulthood, these structures start to decline. We often use the word atrophy. So they start to atrophy. And then what you'll see in that sort of dark gray blue line is the ventricle volume, which is where that CSF is. That starts to radically increase in late adulthood. It's basically, a lot of it is the ventricles taking up the space that is used to be taken up by the white matter and gray matter. So it's sort of filling in that space. So in normal aging, you sort of see a decline in gray and white matter volume slowly. It's not too dramatic. And then this increase in ventricle volume. Let me get the next slide. So how do we measure these brain structures? Well, one of the most important ways we measure them is through magnetic resonance imaging, or MRI. So everybody's probably seen that before or been in one themselves. So MRI uses a strong magnetic field to produce detailed images of the brain. It does not require radiation like an X-ray, and there's no known side effects if it's used appropriately and safely. But how does a magnet tell you how much brain volume or structure you have? So we go to the next slide. So our bodies contain an enormous amount of water, including our brains. And through this, we somehow get at brain structure. It's kind of magical. So water contains these hydrogen, and hydrogen atoms have a proton at its center that's positively charged and constantly spinning. And because of this spin and charge, each proton acts like a tiny magnet in its own magnetic field. And so now, under normal circumstances, if we look at these protons in the brain, they'll be spinning in all sort of random directions, which you can see on the left side of the middle figure there. So their individual magnetic fields sort of cancel each other out, producing no real signal. But when we place a person inside the MRI machine, they're surrounded by an extremely powerful magnetic field, which we call the BO or A0, the baseline field. And this field causes the hydrogen protons to align, as you can see on the right side of that. Some with the field, some against it, but most will actually cancel out with a slight excess aligning in the main field direction, which we call this net magnetization. And this is our starting point for generating an image. And so after that, we apply a radio frequency pulse, shown here as the 90-degree RF pulse that we send. And the protons basically absorb its energy and tip away from their aligned position into a new direction. So if we go to the next slide, what happens when we turn off that radio frequency pulse? Basically, the protons want to return to the original alignment, the baseline alignment with the main magnetic field. And as they realign or relax, they release the energy they absorbed from the RF signal. And this released energy is detected by the receiver coil placed around the head. And luckily, different tissues relax at different rates. So white matter, gray matter, and CSF and ventricles each have different molecular environments, and the size and motion of the water molecules differs between them. So this means they release energy at very different rates in different amounts. So as you can see in the diagram, each sort of tissue type produces a very different signal pattern. White matter produces one type, CSF another, gray matter another. And the coil detects all these signals as electrical currents and sends them to the computer, which we can use to distinguish between the different tissue types. So to put a little bit more simply or summarize, we align all the protons in the brain with a strong magnetic field, knock them sideways with an RF pulse, measure how quickly they recover. And because the different tissue types recover at different rates, we can kind of make a contrast image of the different tissue types. And the end result, as you see in the next slide, is the structural MRI scan of the brain. So the different relaxation times translate into different brightness levels in the final image. So here you'll see CSF appears quite dark and black. Gray matter is where the brain's processing happens, and that appears in these mid-gray tones. And white matter, the brain's information highways, they appear the brightest as the white content. So this contrast allows us to clearly visualize brain anatomy and identify different structures, all without any radiation exposure or invasive procedures. Go to the next slide. So what we can do then is use this knowledge of the different brain structures and volumes to look at how they are affected by aging. So in this particular case, when we're looking at gray matter, we're thinking about volume loss and density loss. So in this particular study, what you can see is you can actually use the volume amounts to make a prediction about someone's age, where their gray matter volume should usually be. And so for people who are aging quite well, you'll see that they're, in that first top left-hand one, their actual age was 32, but based on their gray matter volume, their age looked like they were 22. So this is really great volume mass. Whereas if you look at the bottom right corner, that particular individual's age was 62, but their estimated age based on gray matter volume was actually 81. So for some individuals, you can see quite heavily atrophy that is well outside the normal range for their age group. If we go to the next slide. And so the impact of this is massive. And so one of them is on a cognitive function called executive functioning. So this uses a lot of frontal cortex areas, and it's really considered conceptual thinking. And basically, when you look at the relationship between gray matter volume in the frontal areas of the brain and your executive functioning, before 40, there isn't really a relationship. But after 40, there's this very strong positive relationship. So the more volume you have, the better you are at executive functioning. So what seems to be not really or kind of normal up until 40 becomes incredibly vital after 40 years old to retain that volume in the brain. And so then we have white matter, and we're looking at sort of similar ideas. The volume loss, often seen as also seen as hyperintensities or lesions, basically atrophy of that white matter. And so in these diagrams, this will show up kind of ironically as incredibly more white areas, as you can see in the severe case. And the impact of this, in the next slide, is on processing speed. So in this particular study, processing speed factor, the higher it is, it actually means the longer it takes you to do something. So that's bad. And we see the integrity of your white matter negatively relating with that speed, which is actually saying that basically the better your white matter, the quicker your processing speed, or the worse quality of white matter, the worse processing speed you have. And this makes kind of intuitive sense, right? If white matter is communicating information to all different brain areas, then for you to respond to a complex task, you need that communication to be very quick. And if there's lots of potholes in your highway, then it's going to take longer to get there. And so you see this impact on things like cognitive speed with this white matter loss during aging. And so here we can see normal versus dementia. And when we get to basically the most pathological form of aging in Alzheimer's disease, you see incredible atrophy to both of these main structures, white and gray matter. So these are incredibly important biological biomarkers for healthy aging. Is where's your white matter and gray matter volumes at compared to your usual age group. So now let's talk about quickly a completely different way of scanning the brain, electroencephalography, EEG. So while MRI measures magnetic properties of hydrogen atoms, EEG directly measures the electrical activity of the brain. So this electrical activity comes from neurons communicating with each other. When neurons fire, they generate tiny electrical currents, and a single neuron's activity is really far too small to detect. However, the brain contains about 86 billion neurons. And when thousands of them are firing together in synchrony, their electrical fields sum together to create a strong enough signal to detect at the scalp via those electrodes that you place there. And as you can see in the left diagram, the neurons most responsible for this EEG signal are called pyramidal cells. They're large neurons arranged perpendicular to the cortical surface, and their shape and orientation mean that when they're active, their electrical fields align and add up. And this creates the sort of small electrical fields that are generated that we see travel through the different layers of the brain, through the skull, on the scalp, to where the electrodes are placed on the surface to detect it. So the signal is incredibly small, measured in microvolts, which is a millionth of a volt. So it needs to be amplified before we can analyze it. But once amplified, as you can see on the sort of cartoon on the right side, we get the characteristic wavy lines of the EEG reading. So what do we do with this wavy EEG activity? Well, one of the most fundamental analyses that you can do is decompose it into these different frequency ranges, or what you probably know as brain waves. So the top wave there, that shows sort of what raw EEG activity looks like. It's a kind of like complex, messy signal that's made up of many different frequencies all mixed together. And we can use mathematical techniques like the Fourier transform, where we can separate this signal into component frequencies. So you basically filter out and only look at certain frequency bands based on their hertz. So each frequency band is associated with sort of different brain states and different cognitive processes. And these are typically split into delta waves at sort of 0 to 4 hertz, theta waves from 4 to 8 hertz, alpha waves from 8 to 13 hertz, beta waves from 13 to 30 hertz, and gamma waves, the fastest, from 30 to about 100 hertz in purple at below. And so at any moment, your brain's producing all of these signals, and we can just sort of simultaneously, and we can just split them up into these brain waves through maths, essentially. Next slide. And so when we look at that activity, you'll see in this figure here, if we plot it, so frequencies are on that sort of x-axis and the power of activity in the y-axis, what you'll see is that it has a 1 over f function, which means as you go up in frequency and in brainwave, the power tends to decline. And what we actually find is that the more it declines, the more sharply it declines, the less noise you have. And sort of the more noise in your brain there is, the flatter it is, because it's less structured into those different components. So there's too much excitatory activity happening that flattens out this normal curve that you see as you go across the frequency range. So the takeaway here is flatter is more noisy. And what we see, for example, in this study is that older adults tend to have a flatter curve here. So if we go to the next slide, what we can do is measure this as an aperiodic exponent. So you can just think of the exponent as how sharp is the slope of this decline in power as you move across frequencies and brainwaves in the brain. And the flatter the slope, the smaller the exponent, the more noise that your brain has. So just in sum, then, we've got a few biomarkers of brain aging. So with structural MRI, we see reduced white matter volume, reduced gray matter volume, and increased CSF or ventricular volume. And in EEG, we see this flatter 1 over F lower exponent representing this increased neural noise as we age. So what can we do about this, right? Are these sort of modifiable elements of your neurobiology? Well, what we can look at for targets to modifying them are actually the risk factors for dementia. And so some of these risk factors can't be modified, obviously. So factors that you can't change how old you are. But there are modifiable factors that predict the getting dementia. And these include things like physical activity, depression, sleep, diet, social and cognitive engagement. And by looking at these, we can actually sort of target them to reduce your brain aging. In the next slide. So in a recent report last year by Livingston, what they actually found was that about 45% of all dementia cases are potentially preventable through modifiable factors. So that's nearly half of all dementia cases could be stopped by these modifiable factors. So there's a lot of power here to change the trajectory of Alzheimer's diagnoses in our futures. Go to the next slide. And so what we wanted to look at in a study that we got published in Age and Aging late last year was, well, if we look at just the modifiable factors that predict dementia, how do they relate to these different markers of brain aging? So structural markers, white gray matter, and ventricle volume, and then the EEG exponent that we just discussed earlier. So if we go to the next slide, what we did here is we basically used this model of dementia risk. So you have all the different factors that predict dementia, and then we took out the ones that were non-modifiable. So we excluded participants with diabetes, stroke, and traumatic brain injury. And then in our models, we controlled for age, sex, and education. And so what we were left was with the dementia risk score that represented for each individual participant, how much modifiable dementia risk do they have? So the more risk, the worse it sort of potentially is. And we did this in older adults from 50 years and above. So if we go to the next slide and look at the results of this, what we actually found was that when we looked at the structural MRI, there was this negative relationship with white matter volume and dementia risk. So that is to say that the increased modifiable dementia risk meant that you had smaller white matter volume. So this was in healthy older adults. It wasn't with people with dementia. So what we were seeing is that these relationships between your brain structure and what you're doing in your life and your lifestyle was actually showing up in the structure of white matter, such that you'd have smaller white matter if you were living a life with more risk of dementia based on modifiable factors. And if we go to the next one, and when we looked at the EEG activity of our participants and we modeled the exponent that we were discussing before, what we found was those with increased modifiable dementia risk actually had flatter slopes, which meant so smaller exponents. So suggesting that not only did they have less white matter and that sort of structural impact, but functionally it looked like their brains were a bit more noisy because of this lifestyle of increased dementia risk. So what this is sort of the takeaway from this study was, if we go to the next slide, was that your lifestyle is already kind of being painted on your brain, even well before any sort of dementia diagnosis. The good news, though, is that the paint is still wet. So if we look at other studies, again, the next slide, what we see is some really important results looking at modifiable factors and intervening on them. So firstly, I want to talk about the hippocampus. Hippocampus is a really important structure in the brain. It's called the hippocampus because it kind of looks like a seahorse, and hippo means Greek for horse, and campus means Greek for sea monster. So that's why it's called the hippocampus, which I always thought was quite cool. If we go to the next slide, what we find is that if you look at how much people exercise per week, the more people exercise, the bigger their hippocampus volume is. And if we look at the next slide, we also see that in these two different studies, in an Irisin study and in a Muller study, they showed that actually intervening, so increasing exercise amongst older adults. So in the first study, their mean age was 68 years old. Their hippocampal volume actually increased. And if we look at the below study, the Muller study, what you see is that dancing interventions actually increase hippocampal volume above and beyond just aerobic exercise, likely because it's synthesized multiple risk factors, including cognitive engagement as you're learning dance routines, and obviously physical activity, and then also social activity, because dancing usually involves meeting up with lots of people. So the takeaway from all this is that modifiable factors of dementia can not only protect against brain aging, but it appears that they can reverse some of the aging effects that we see in the brain, both in structure and in function. And brain scanning methods like the ones I've described, there are only two versions, but there's many more to go through, which our courses do go through, can track these changes and provide potential biomarkers for reversing the effects of brain aging and increasing your brain resilience over time. Thank you.
Okay, sorry, I was just organizing the buttons on my screen. So thank you very much, Tom. That was very insightful. Excellent presentation, lots of lovely neuroscience details. And we do have a few questions that have come in. So I'm just going to have a quick look through, and I might try and focus on some of the ones related to the presentation that you've done to start off with. So I'm just going to have a look. Actually, I'll just go down the list. So first question, can you talk about how much of your course covers neuroscience for optimal mental health and how much focus is on mental ill health? So I guess I'll answer that really quickly. And yes, we do cover neuroscience for optimal mental health as well. For example, we talk a lot about the benefits of lifestyle factors and what they can do in terms of enhancing brain function, as much as how they can then be used as, you know, a treatment modality for mental health disorders as well. Okay, question for you, I believe, Tom. How is healthy brain aging related to older persons? Oh no, this is for me. Included in the courses. Is there a major stream learning course associated with the impact on aging and healthy brain? Yes. So we actually have a whole course that is called Healthy Brain Aging, and it does cover the brain aging process from, you know, normal cognitive decline, normal aging processes, right through to, you know, disease processes such as dementia, particularly Alzheimer's, but also we do look at frontotemporal dementia and other forms of dementia. And then it does have a huge focus on how these lifestyle factors that Tom has talked about in this presentation can actually impact both healthy brain aging and, again, that disease brain aging. Okay, I am just going to go down the list, Tom, so that's probably easier than bouncing around. So how does the master's qualify one for admission into a PhD? So the master's is definitely designed as a pathway to PhD, and what it does is it gives you that research experience that if you haven't got an honours, for example, it can do that, but it also gives you that research experience specifically in the mental health and neuroscience area, if that's something that you're wanting to do your PhD in. In terms of sort of qualifying for PhD admission, that, you know, sort of is dependent on other factors as well, but it's definitely designed to be a pathway into PhD, and it'd just be a case of talking to the university that you're wanting to apply to and understanding a bit more about that. Okay, gosh, we've got a lot. I'm trying to, and I've lost my place. Sorry, bear with me, everybody. Okay. So are there opportunities to discuss course content and assignments with the instructor or course coordinator beyond discussion boards? Actually, I'll pass over to you, Tom, while I just grab a quick drink. So if you wouldn't mind responding to that one about the course.
Yeah. So yes, there are opportunities. You can always email the course coordinator specific questions if you're not comfortable talking on the discussion boards. We usually ask students to try and put their questions on discussion boards purely for the ability for other students to see those answers if they're interested. So, you know, an answer for you is potentially helpful to everyone, but they're all individually answered by either the supervisor or some of our staff that's working with the course. So it's not a discussion board that's relying on other students to answer your questions. You still get direct contact with the supervisor. But of course, yeah, if you have specific questions, you can email the supervisor, the course coordinators. And then also there are Zoom drop-ins that happen before assessment tasks, where you're able to ask the course coordinator any questions you have about the assessments that are coming up as well. So that provides a live sort of face-to-face, well, on Zoom discussion as well for any questions that you have.
Yeah, excellent. Thanks, Tom. And those Zoom sessions are also recorded, so students are able to watch them later if they're not able to attend them. Okay, so great question. Is there an advantage to enrolling in the grad dip rather than starting with the grad cert? I guess it's a case of what your eligibility criteria is for the for the different degrees. And the only other thing I would say is that the graduate diploma does have the 4 courses offered each trimester at the moment. So whereas the grad cert is part-time. So it just depends how you want to approach it. But if you start, as I said, if you start in the graduate certificate and then you're enjoying it and you want to go on to the graduate diploma, it's just another quick application and you can carry on. So the programs are nested. Lots of course questions. So is the graduate diploma and master's accredited with psychotherapy counselling? So it's not an accredited degree at the moment. It's something that we have on our radar to look at down the track, but currently it's not accredited in that sense for any particular association. So how could it act as a pathway to another degree? Might be worth. Okay, so yeah, so I guess I'll just talk a bit broadly about the type of students that we have and what they tell us they're doing with their qualification. So we do have actually a lot of people already in counselling and mental health and psychology and social work degrees who are using the MHM program to really complement their current degree and get a better understanding of the neuroscience behind the things that they're dealing with their clients. And we also have, as I said, students that are using this knowledge to move into more, I guess, well-being based jobs within their current professions, and also just getting that we have got OTs who are working in mental health who then use this degree as a way to get them further along in terms of getting into that mental health space and having that deeper understanding. So there's just a few examples of the, I guess, the different types of careers that are using our degrees to, for various different ways, whether it's to enhance their careers or to move into something else or give them a more kind of specialist outlook from that neuroscience perspective. Hope that answers it. Okay, I have a question for Tom. So just a bit of context. So the question came through while the decomposition of EEG in the brainwave slide was showing. So hopefully you understand that, Tom. And I guess it's a comment with a question. So this brings together the work of Norm Deutsch as well, that neurons that fire together wire together. Doesn't it? Question mark. So do you want to comment on that, Tom?
Yeah. So yes, the neurons that fire together, wire together, is a little bit more about how they communicate. So synaptic weights will become stronger between neurons, and synaptic connections will become stronger with neurons that fire together. So the more neurons fire together, the stronger their wiring, the easier it becomes for them to cause each other to fire, which is a little bit different to what I was saying with the synchrony causing the EEG activity. So what we need is synchronous firing of neurons in order to create a strong enough electrical signal for the electrodes to measure. So it's actually less of a function of the brain that we need. With the point I was making about the need for that synchrony, we actually just need it in order to get a signal from the brain with EEG. So actually, EEG can often miss a bit of the asynchronous activity that isn't causing a strong enough electrical change to be measured by the electrodes. But yes, it's also true that neurons that fire together wire together strongly as well.
Thanks, Tom. We have a question about, do any of the courses go into transcranial magnetic stimulation, so TMS, or electroconvulsive therapy, which is ECT? Yes, absolutely. So we cover some of the traditional treatment modalities. We look at the use of ECT for particularly things like treatment-resistant depression, but we also do cover those more novel treatment approaches, including absolutely TMS, which is actually one of the treatment modalities that Tom covers this in his course for neuroimaging, but you also see it pop up in other courses as well, where we do discuss the literature around lots of novel therapies for lots of different mental health disorders, including TMS. So great question. Okay, I am conscious of time. We've got about a minute left, and I can see that we have got a stack of questions to get through. So I just want to reiterate that we've loved all your engagement and the questions that are coming in, and we are not likely to get through all of them now, but what we will do is follow up later via email with some answers to the questions that we have had come up. So I'm just going to try and find a little quick couple to finish off with. Oh, this is a really interesting topic, and I sort of don't want to put Tom on the spot too much, but the research around menopause and the impacts on the brain in terms of menopause is definitely becoming a hot topic at the moment. So one of the questions, Tom, was about what does MRI tell us about menopausal brains? And obviously, with your healthy brain aging program, you would be sort of looking at that demographic. So I guess just a quick question, is that something that was considered in your research or something that people are looking to do down the track?
Yeah, and just on that point, there was also a similar question to this. So one person wrote, so regarding the frontal cortex volume and executive functioning, is there imaging differences with people who have conditions such as ADHD or ASD, as executive functioning is often an area of challenge? So what the neuroimaging course specifically actually goes through is multiple of these. In terms of the module content, we actually don't go into the menopause, but we do go into ADHD and ASD. But you do tend to find these imaging differences. What the courses often allow, and what students have been able to write essays or responses to, are these personal interests that they have. So often students get to choose an essay topic that they want to write about. So you can integrate your understanding of how to read neuroimaging papers that you learn through the modules and then apply that to a field that or an area that you're interested in and can get feedback on that. So it can be menopause, it can be ASD, it can be ADHD, etc. So it's about sort of teaching you one of the fundamental skills, which is can you read and interpret a neuroimaging paper? And that might be taught in certain mental health disorders and fields, but it's also about being able to apply that skill into new areas or any areas of interest and giving you the opportunity to do that as well.
Excellent. Thanks, Tom. I have just had a quick scan through. We do have some really awesome questions, and I'm just going to try and zone in on a couple more, but we really will respond to your questions in a follow-up because there's some really awesome ones in there which will be great to answer. I just want to answer, one is about, do we address the issues of Indigenous health and wellbeing? This knowledge is so important towards healing. Yes, absolutely. And there's also another question about the closing the gap targets. Yes, so we do talk about lots of different populations and priority populations. We definitely incorporate Indigenous health, First Nations people. We have a strong focus in terms of that, looking for recovery and a strengths-based approach. And we cover that across a number of different courses in different contexts, so including the suicide prevention course and also the mental health and neuroscience course, where we cover kind of general demographics around the prevalence of different mental disorders, and also intergenerational trauma and those types of contexts in our stress-related disorders course. So very much covering those very important topics. Okay, I'm going to finish with a really great question. And then, yeah, we'll wrap things up and we will get to answer the rest of these questions. But I really like this one. So, question for you, Tom, just to close things out. Where do you predict will be the big areas of, I guess, funding and research in neuroscience for the future? And is brain aging and longevity one of them?
Yeah, that's a great question. So firstly, on the brain aging side, personally, I actually think it's the biggest issue facing neuroscience. So I feel like neuroscience is a very new field relatively to the classic physical sciences. And they've sort of allowed in the medical science field the body to survive longer. So we can get people living into their 90s and 100s now, but not necessarily well with a good cognitive function and brain sort of health. And so the task set about neuroscience at the moment is, well, we've got the body living longer. How do we get the brain to keep up? And so we're a little bit behind the more older sciences here, and it's getting a lot of funding because as the population ages, things like dementia become a massive societal burden, and it has terrible impact on many people's lives. So yeah, it's getting a lot more funding and is absolutely vital to our field. And then, of course, there's the mental health side of things where neuroimaging and understanding neurobiology can help us to try and both predict and intervene on mental health disorders. And of course, it hasn't been working that well yet. So there is still so much to learn. The brain is so complicated and people's individual experiences are so diverse for all the different mental health disorders that, yeah, there needs to be so much more work done on understanding the neural substrates underlying them, so that we can improve treatment outcomes for those with the different disorders. So those two areas, brain aging and mental health, seem to be the most biggest impactful areas that are going to get the most funding in the future, and deserve the most funding, in my opinion, because they are sort of the more medical questions that need to be answered.
Yeah, awesome. Thanks, Tom. Yeah, I echo that. I mean, medicine has improved so much that we are living longer, but we're living longer with more years of disability, and that includes things like cognitive decline and, issues with brain aging. So, excellent question to finish off. Now, I just want to point you all towards the link in the chat for any follow-up questions. But other than that, we will definitely get to all of these questions. I've really enjoyed sharing this information with you, and thank you, Tom, for an excellent presentation. Thank you, everybody, for joining us this evening. I hope you too have also enjoyed it, and as promised, we will get back to you with those questions. So yeah, for now, thank you very much. Enjoy the rest of your evening, and yes, it's been a pleasure to be with you this evening. So thank you. Bye, everybody.
Thanks, everyone.